about producer theory. Producer theory is really easy to understand once a person has gone through consumer theory. So, first of all, we begin with what a production function is. Okay, the functional relationship between inputs and output is called production function. So, for example, if I say output is a function of labor and capital, this is a production function. Now, this production function can take various forms. So, for example, I can have a general production function like this. So, I would like to say this as a Cobb-Douglas or a well-defined production function. And this would look something like this. Output is equal to k to the power alpha L to the power beta. So this is showing me some relationship between labor, capital and output. Similarly, say output is equal to alpha k plus beta L. This is again showing me some relationship between output, labor and capital. But now this is in the form of substitute inputs. Similarly, I say output is min of AK comma BL. This is again showing me relationship between output, capital and labor. But now this is in the form of complementary goods. Right? So, and other forms as well, like output is root k plus L. So this is nothing but a quasi-linear function. Similarly, I can have output is equal to max of k comma L. So this is a max function. So basically, I have to show the relationship between output, labor and capital, and this relationship can be in any form. Okay. Now let's define something which is known as an isoquant. So to define what an isoquant is, let's see what is iso. Iso means equal or same, and quant means quantity. Okay, so any curve that gives you different combinations of labor and capital such that output remains constant is called an isoquant. So for example, this. So I have labor here and I have capital here, and I say I want to produce 10 units of output. So I produce an isoquant. This combination of labor and capital will also produce 10 units of output. This combination of labor and capital will also produce 10 units of output, and this combination will also produce 10 units of output. So different combinations of labor and capital such that you produce a given level of output is called an isoquant. Now, if I want to produce 11 units, I will have a higher isoquant. So, higher the isoquant, more is the units that you are producing with it. Just like the indifference curve, higher the indifference curve, higher is the utility. Similarly, higher the isoquant, higher is the quantity that you are producing with it. So now let us talk about the slope of an isoquant. So for example, so first of all, let's see what does an isoquant tell you. It tells you the relationship between output and input. So different combinations of input that produce a given level of output. So let's total differentiate the function. So I'll get dq is equal to differentiate the function with respect to L dl plus differentiate the function with respect to k dk. So I'll get dq is equal to, now see this, f was nothing but q. So q is nothing but a function of this. So this thing and this thing are equal. So this basically, this part tells you how does output changes when labor changes. Similarly, this part tells you how does output changes when capital changes. Now this is called the marginal output with respect to labor. This is called marginal product, or this is output or product. So marginal product with respect to capital. So how does output changes when labor changes is marginal product of labor, and how does output changes when capital changes is marginal product of capital. So the equation becomes marginal product of labor dl plus marginal product of capital dk. Alright, so now what do I do is, I know that when I construct an isoquant, I fix output at some level. That level can be 10, 20, 30. I'm fixing output and I'm saying different combinations of labor and capital that give you that level of output. So because output is fixed at some level, differentiation of this thing would be 0 because it's a constant, it's fixed. So dq is 0. Okay, and now I know that the slope at any point is perpendicular by base. So what is perpendicular? How does capital changes? And what is base? How does labor changes? Right? So this is nothing but the change in capital, and this is nothing but the change in labor. So perpendicular by base, or its slope of isoquant, is actually dk by dl. And now I have to find the value of dk by dl using this equation. So my equation is 0 is equal to mpl dl plus mpk dk. So minus mpk dk is equal to mpl dl. So dk by dl is equal to minus mpl by mpk, and this is nothing but mrts. So the slope of isoquant is called mrts, is equal to minus mpl by mpk. So mrts full form is marginal rate of technical substitution. So just like MRS, our marginal rate of technical substitution is also diminishing. And let us try to give reason